Hello and welcome to our computer vision project for Comp 4301. Today we'll be presenting a simple bird classification model used to identify different species of birds. So to get started with our problem statement, ornithologists are often faced with challenges of identifying the birds that they capture through video cameras. It's often difficult for these guys to classify the birds just from looking at a particular image. This is made even more difficult when we account for the fact that many bird species look very similar just from a simple eye test, especially from far away. So say you're out and about and you take a picture of a bird you see out in the woods somewhere, and you want to classify the species. Our project is able to aid in this endeavor by classifying a series of bird species available in Newfoundland and Labrador. By using a series of computer vision techniques, we are able to classify several different species of birds with an 87% accuracy. But before we demonstrate, we'll first go over how we actually built this model. Firstly, we curated the dataset by using the Caltech Bird 2011 dataset. This dataset contained over 100 different species of birds. For the purpose of our project, and for the sake of increasing accuracy of the model, we only used the species that were available within Newfoundland. This gave us a higher accuracy as we only needed to classify a select number of bird species instead of the 100 different species found within the dataset. To create the core of the model, we put the images through 3 convolutional layers with max pooling using a 2x2 kernel. We chose these values based on our research from other projects that use the Caltech dataset, as these seems best for getting the highest prediction accuracy. We also had issues with overfitting, where our testing accuracy would skyrocket whilst our validation accuracy would remain at around 50%, as you can see here. This wasn't ideal for what we were trying to accomplish, so in constructing our model, we made a few key decisions to help increase our validation accuracy. To fix the overfitting issue, we added data augmentation by adding flipped and rotated versions of the same images to our dataset. We also added dropout layers towards the end of our model to decrease the overfitting issue. We also decided to add more data into our model by downloading images of the same bird species from Google Images and adding them to our dataset. We also made sure to clean this data for any faulty images as well. We decided to do this based on some other projects that we found online that use similar strategies for creating image classification models from scratch. So in the end, here is our final model. We can see the convolutional and max pooling layers. We can also see the data augmentation and dropout parts of the model that we used to fix the overfitting issue. And so in the end, this model was able to achieve an accuracy of 87% as discussed before on the different bird species that we had in our data set. And so finally, here's a demonstration of how this all works. We developed a simple script using Python and Tensorflow to classify the series of images that we had. So as we can see, the program gives us 2 options, one to create the model and one to use that model to predict images. So we'll go ahead and run the Python bird create command. This will train the model and save it into our directory. So we can just let this run for a bit and then come back when we're done training our model and see the results. So we're done training and now we can see the results and the performance of our model. As we can see, according to our graph, our model has around an 87% accuracy as discussed before in predicting the images of birds that we have. So now we can go ahead and use the test portion of our program to try to predict an image of a cardinal, as we'll see in a moment. And so if we want to test our model against a bird image that isn't part of our data set, we simply run the same Python script using the test argument followed by a pass to the image that we want to classify. As we can see, an image pops up with the name of the bird on the bottom left of the image. This concludes our computer vision project. Thank you for watching.